Got a song from Listening Pleasure, fits the tune of the day here.
Want some whiskey in your water, sugar in your tea? What's all these crazy questions they're asking me? This is the craziest party that could ever be. Don't turn on the lights, cause I don't want to see. Mama told me not to come. Mama told me not to come. That ain't the way to have fun, no. Open up your window, let some air into this room. I think I'm almost choking from the smell of stale perfume. And that cigarette you're smoking, I'll scare me up to death. Open up the window, sucker, let me catch my breath. Mama told me not to come. Mama told me not to come. That ain't the way to have fun, son. That ain't the way to have fun, son.
Hey, that was pretty good. I was just looking over your comments on the equations that I gave you to look at. So we had some great ideas here. We did some of this before the break. We talked about polar coordinates the last time, and I said, hey, now I just want you to play around with this curve. So let's look at some polar graphs here. I'm going to go into a different color. Oops, I got to turn my pen on. And there we go. Now we can fly. I don't know what color. Let's try some of this cool blue right here. It looks like it's pretty good. All right, so let's look at the polar graphs of, polar graphs of sine, cosine, slash cosine. All right, just the regular constant graphs. All right, R equals a constant, right? And let's see, I was looking through here. R equals a constant. And man, I got tons of comments. You guys are awesome. So Amanda says it's negative and reflects over the y-axis, big and more stretches. I see R first creates a circle. It's the radius of a circle. Chayton, here we go, radius of a circle. Dash, radius of a circle. So we're getting, most people are all saying that we've got a circle. All right? And if we remember what remember R equals a constant, that means that the radius is just going to come out to that far, just like most of you are telling me, and that's what you're going to get. All right? If we go R equals theta, or some other number, Gavin tells me I've got a spiral, all right, and let's see what she got here. R makes a spiral, all right, let's see, I see some more stuff about making a spiral starting at 0. Yeah, I get Maddie saying the same. So a lot of you are saying, hey, we're going to get a spiral-looking graph, and you're correct there. So let's go back to this. So here, we're going to get some spiral-looking thing. All right, that's pretty cool. Some of you may have heard of the spiral of Archimedes. All right, so that's what you get when you just do that. But the interesting graphs were when we had R equals A, all right, sine B x minus C, okay, plus a D. And what did each one of these things do? Let's see. So I'm looking through some more stuff here. A changes the amplitude, B changes the frequency, C moves it up and down, D moves it up and down. All right, let's see. R equals A stretches it vertically, B stretches horizontally, C shifts the graph, D shifts the graph. Let's see. A changes the radius, it's negative, rotates the graph 180. B changes to make the graph into a leaflet thing, gummy kind of deal. I've seen that. rotates around the origin. All right. Let's see. I've noticed that. So there's a number of different things I'm seeing. Here somebody talks about wavelength. All right, a wave graph. Okay. Well, let's give it a little quick look here. All right, so if I come into this Desmos document, which is the one that we used in the beginning, way back when we had the closure, all right, polar cosine graph. If I change the A value here, all right, just changing that, I'm going to play that, and by golly, by gosh, whoever said we get a reflection and we get a stretching is correct, right? That's what's happening there. All right, definitely that's what's happening. So the A graph, the A value on that doesn't really, just kind of stretches that circle out, and a reflection. Very much related, you might remember, to the amplitude. That's what the A value was, where it would stretch the curve. So there's not a whole lot of difference there. All right, let's take a look at what C does. All right, I want to skip B for now. And C does some sort of a rotation depending upon its value, negative or positive. All right, I'm seeing that we're getting some type of a rotation there around that origin. So I'm just going to make this 0 if I can. Okay, I can see that when it's going smaller, it goes this way. Let's see, that would be clockwise. And then when it starts to move in this direction, it goes counterclockwise, but we're still getting a motion like that. All right, so I'm just going to click on this. I want it to be 0, and I don't want a negative in there, but there we go. Okay, so that's what C does, right? It's just a rotation around the origin of the regular old cosine graph, okay, which is a circle, right? And that shouldn't surprise us that we're getting circles. D, let's see what it does. Okay, D does some strange things. I'm not even sure. It kind of blows up, and then I get this little loop inside there when I mess around with the D. All right, so when it's positive, it just kind of blows up, and when it goes down smaller, and at some point, like I'm getting these little loops when it's between 1 and -1, it looks like, all right, is when I'm getting those loops, all right? So that's kind of interesting that I get a loop inside there, all right? So that's what D does, okay? But the real interesting one is B, because I get these crazy curves. Now I'm going to see if I can slow this down a little bit. I'm trying to slow it down. This is not slowing it down. There, that's slowing it down, maybe. Really slow it down. So I wanted to see kind of what was happening. All right, so I'm getting some loops. All right, let's pause this, and let's take a look at this a little bit more. And I'm going to change it so that it starts like at a -5 and goes to a 5, but I'm stepping it by 1. I'm going to make it kind of boring, but that's what I want to do. All right, so let me turn off the red one for now. And let's start off at 1. So we get that circle, right? And then we go to 2, and now we get this leaf thing that someone was talking about, right? And now if I go to 3, I still get leaves. And if I go to 4, I get leaves. But the question is how many leaves are we getting, right? So if I go back here to 1, I just have the circle, right? And when I go to 2, I see I have 4. And when I go to 3, I have 3. And when I have 4, I got 1, 2, 3, 4, 5, 6, 7, 8 of those leaves. And 5 gives me 5. So I guess if we had 6 in front of there, then what do you suspect we would probably get? I mean, we'd probably get 12. All right, so what I'm going to do is go into here, right? Now, that was the cosine one I looked at, I believe. Let me check it out real quick. Yep, it was. So I'm going to erase this and put cosine in front of that because I want to be consistent with what I'm doing. All right, and let's write down, remember what we said A did. All right, so somebody said that A, first of all, it did a vertical stretch of the circle. All right, it stretched the circle out. Anyway, so wouldn't it be horizontal stretch also? Yeah, well, technically it goes either vertical or horizontal. It's a circle, it's symmetric. So you're right. Maybe I should just say it's a stretch, right? So A stretches things out. It's a stretch. Stretch of the radius. Because remember, the normal graph is just a circle. All right? Okay. And let's scoot up a little bit here. Let me get rid of all this junk that I have. I don't know why this shows up. We're going to get rid of that. All right, let's go back into this and we'll go B. All right, now B, if B is an even number, okay, then we ended up getting some leaves, right? All right, so we got 2B leaves. Leaves, not leaves. Come on, dude. Leaves. Or sometimes they're called petals. All right? If B was odd, then we just got B petals. All right, that's what we ended up getting. All right. Now, let's see. What about C? Do you remember what C did? Yeah, C just rotated circle or the graph around the origin, right? Okay? And D went ahead and gave us that little, when D was between, when D was between -1 and 1, we ended up getting the loop. All right, inside that thing. So it kind of looked like, so we got something that looked like this, right? And then we went inside and it came out. Right, so that's what that did. So the question was, does it do the same thing for sine? All right, so let's go ahead and try that out. So I'm going to go back into this, right? And I have one for sine also. And here that is. Now, first of all, we notice that the circle is facing upward rather than sideways. All right, so I'm just going to kind of play the A to see what that does. Maybe. Come on. Come on. What's going on here? Well, I'll just grab it, move it myself. So I can see that, yep, the same thing's happening no matter what I do with the A value. It's just doing it vertically. All right, I'm going to get A back to 1 so that I can have that. There we go. All right, I'm going to do the same thing. Let's come down here to C, see what C does. All right, there's that rotation, right? There's that rotation. If I'm going smaller, it's rotating clockwise. If I go bigger, it's rotating that way, counterclockwise. Let's put a 0 in there. Nothing's changed yet. I'm going to try D now. Okay, there's the little loop coming on right there. Same idea. All right. As before, nothing much has changed. I'm going to zip that back to 0. All right, finally we go to the B. And let me move this in a little bit so we can see it. Remember last time I changed the B, so let's do it again today. -5 on this one to 5. I'm going to step it by 1. All right, and now I'm going to try it here. There's 3, so it's the same as before. There's 3. Let's try 2. Oops, went too far. 2 is giving me 4. 3 gives me 3. 4 should give me 8. So forth. So it really doesn't change it just changed the look of the graph a little bit because sine started up on the top rather on the side. But other than that, we're getting the same thing. So it really doesn't matter whether it's a sine or a cosine graph. All right, so I'm going to go like this. I'm going to put a sign there, and then over here, I'm going to tap this, get this nice fire engine red, and put sign there because it doesn't make any difference which one it is. Now, some of you are probably going, oh, wow, I wonder what tangent does. Yeah, well, you can try that one, but we're not going to spend a lot of time messing around with that. All right? So, let's see. What do I want to do here? So now that we know what those things look like, we're going to kind of give them some names. All right? So I'm going to talk about some of the names of these things because they do have some names. So when you have a graph that has those petals, they call that a rose curve. Okay? So your petal-like graph, your petal-like graph is a rose. Right? And they usually say, here's how many petals it has. All right? They call that a rose curve. If it has a little loop, it's called a cardioid type of graph. And mainly that's because it has that little loop in there. So it looks kind of like, it looks kind of like a cardioid. So it has like this. Right? Oops, I didn't do that very well. Try that again. So it kind of loops around. I'm not getting it in there, guys. Sorry about that. I drew the first one better. So let's see if we start. This one's going to go like this. And kind of loop back in, something like that. So you're kind of getting a cardioid. It actually indents a little bit and comes out like that. Okay, that's probably a better one. All right, and that's called a cardioid type of graph. All right, when you have those. Okay. Sometimes they call them limicons also. You might see that word. I've seen it both ways, limicons and cardioids, right? And then the rose curves. Other than that, that's pretty much what you're going to see with these, all right? Let's see. I'd like to show you where these are coming from, but I'm kind of concerned about the amount of time it's taking to do some of this, so I don't want to take up a lot of time going over. It takes a little bit to show where these things come from. Let's do one real fast here. I just want to show you kind of why the general graph comes in. Let's try that. So I'm going to make a little table here. All right, and I'm just going to do R equals cosine theta. All right, and we're going to put a theta here and an R here. Okay. All right. So let's start out at 0. Okay. So then we put theta in, 0 in for theta. Cosine is going to give us, we can either look at our chart, we can look at it on the unit circle, but we know that we're going to get a 1 there. All right, so when I have the graph, I'm going to change this to a different color, I think, to do the graph part. Come on, give me this. That looks good. Oop. There we go. Okay, I'm going to put a 1 right there. All right, now I'm ready to do the graph then. So I'm going to get a 1 right there. So then let's go with, so we can go with either radians or degrees here. Let's go with 30 because it's a little easier with degrees. All right. So 30 degrees. Okay, if we take the cosine of that, we're going to get 0.86. So then at 30 degrees, I'm at 0.86, so it goes like that. Or the square root of 3 over 2. If I go 45 degrees, I know I get the square root of 2 over 2, so that's 0.07. So 45 degrees would be just a little bit smaller. Then if I do 60, I got a half. So 60 is about a half. And all of a sudden you start to see there I get a 0, and there's that. All right, so then here's that circle graph that we're getting, right? So then if we continue to do this, so I go 120, all right, now at 120, I'm going to get 0.866, but remember that it's negative, so 120 is up this way, but it's going to shoot me back 0.866 in the other direction. All right, oh, no, sorry, 0.5, my bad. It's going to shoot me 0.5 bad in that direction. All right, and then if I add another 45, or excuse me, go to the 120, go to 135, okay, that's going to be 0.707, but it's in the negative direction, so that's going to shoot it back this way, and then we can see how we're going to get the bottom half of the curve. So the bottom half of the curve is going to happen when we're all the way down to 180, because that's going to shoot us back down to here at -1, which shoots me back to 1, all right, at that point. Because remember, 180 would be over here, but the -1's going to shoot me back. So it's already completed the circle. So then what happens in the third quadrant is you're down in the third quadrant, but it's going to shoot you back up into the first, because they're all negative. So actually, it goes around the circle twice. Okay, and the same thing happens with the sine curve, and that's why you get that normal thing. So what I'm going to do is just have you play around with some of these problems. I don't know if I assigned this or not, because I don't think I did. And I'm going to change the directions a little bit on here. So look at the directions that I give you. And then we'll come back on Wednesday, because remember we're doing every other day, and we'll go, how do we get these leafy petal-y curves, and how do we get those, and then we might move on to some other stuff, okay? So anyway, hey, peace out. Hope you enjoyed the music. Later.